Okay, let's do uh, the last exercise from chapter 6, question number 9. Okay, so we just have to read the question properly and draw the diagram. If you can draw the diagram correctly, then this kind of questions is very easy. So let's read the question first. A ladder 10-meter long reaches a window. So see, first thing you have to remember is they're saying window, right? So window, let's say the window is here, okay, and it's at an 8-meter height above the ground. So let's say this is the ground. Yes, so whenever they say window or wall or height of a building or pole or tower or whatever, okay, it's always going to be 90 degrees because wall, if this is the ground, we never build wall like this, right? It's always going to be like this. So whatever it is, be the tower, pole, whatever it is, it's always going to be straight and 90 degrees. Okay, so they're saying a ladder of 10-meter long, which is a window. So we know that whenever we keep a ladder, it's always inclined to the wall, right? So that we can climb up here. So it's always inclined to the wall. Yes, so the ladder is 10 meters now, and the window is at a 8-meter above the ground. So from the ground it's 8 meters. So the question is, find the distance of the foot of the ladder, which is this. Let's say this is the window, this is the ladder, okay, W, no, window, ladder, and then this is the wall or base to it. So the ladder is being kept at the window, and then they're saying from the base of the wall to the foot of the ladder, we have to find the distance. So this we have to find. So we can see clearly that the ladder, the window, and the wall and the ground forms a right angle triangle, right? So if it's a right angle triangle and you know two of the sides, then you should always use Pythagoras theorem, right? You will be studying this kind of questions in chapter 9 also, but there only one side of the sim will be given and another angle will be given. There we have another method. Okay, so exam there, this question is from this chapter, this question is from this chapter. They'll never say that, right? So what you have to know is, if two sides of a triangle is given, then and it's a right angle triangle, always use Pythagoras theorem. If only one side is given and then one angle is given, then don't scratch your head too much trying to use Pythagoras theorem there, okay, because you'll never find the answer. You need at least two sides. So it's quite easy. So let's just say let's start in triangle WLB. Okay, in triangle WLB, the hypotenuse is the one opposite to 90 degree. Wherever the 90 degree is, opposite to this is called the hypotenuse. So by Pythagoras theorem, hypotenuse squared, okay, hypotenuse is always squared, and this side you can write whatever side you want. You can write LB square first, or you can write WB square, doesn't matter which side you write. Okay, let's say WB square plus LB square. So this is always going to be this thing, whether this is given, or this is given, or whatever, it's the unknown value. Maybe sometimes it will be this, sometimes it will be this, sometimes, but always you're going to write the hypotenuse on the left side and the other two sides on the right side, and then addition sign between them, and everything should be squared. So this is 10 square, WB we got 8 square, LB square, just gonna keep it as LB. 10 square is 100, 8 square, if you bring it this side, it becomes minus. So 8 square 64, ito fali nilo minus ho na, and then LB do LB dekho. So square ito fali potentially root over ho jao. 100 minus 64 is 36. Okay, so equal to LB, because the square is being sent, so that is why it's becoming root. You have to remember that, okay, because I've seen some students put root and still the square is there. Okay, so root over 36 is 6, right? Because 6 into 6 is 36. Therefore, distance of the foot of the ladder from the wall is equal to 6 meters. Done. Quite easy, right? So that's it. Let's go to question number 9. And yes, you have to draw the diagram, because all these names are related to diagrams only. I've already seen so many students not use diagram. So okay, let's do number 10. let's read the question first. In the textbook, it's given a guy where this guy is not there, okay? So it's a printing mistake. So a wire attached to a vertical pole. So let's draw the vertical pole first, okay? Vertical pole of height 18 meters. So the pole is 18 meter, is 24 meter long. So the rope or the wire is 24 meter long, okay? And there's a stake. Stake means itu latira, chakon rakida do pandi boli rusi. And a stake attached to the other end. So tang na pole is 18 meter, okay? And there's a wire which is 24 meter. And then from the top, we have to stretch the wire in such a way that on the ground, how far away from the ground should you put the stack where the wire is being pandibolena? So from the top, how far should be the stack so that the wire is tight, okay? Not loose but tight. So the wire is 24 meter. So the 24 meter is stretched out. So now they're asking us how far this distance is. Now you already know how to do it. So let's say the names are A, B, C. Okay, we need to find this. It's quite easy. We'll just use Pythagoras theorem. So in triangle A, B, C, we can say, and you know that I've already told you a vertical pole whereas though it's 90 degree, right? So opposite to 90 degree is the hypotenuse. So by using Pythagoras theorem, we can say AC, but you have to write the names of the triangle first, okay, before you put on the values. AB square plus BC square. As I've already told you, hypotenuse first, and then the rest two in any order you want. So AC is 24, AB is 18, BC we don't know. So 24 into 24, let's do it. This has to be done in rough section, by the way. 4, 4, 16, 6, 1, 4 to the 8, 9, 4 to the 8, 2 to the 4. So we're getting 6, 7, 5, and then we have to do 18 into 18 also. Let's do it. 18 into 18, it is 64, 4, 6, it was 8, 14, and then 18 was 18. So 4 is here, 12 is here, 3 is here. So if you bring this one, 18 square is this one, and then you bring it this side, it will become minus, equal to BC square. Squares any this side, it will become root, and the square is gone to this side, so only BC will be left. So let's subtract 576 from 324 from 576. So 2 will be remaining, 5 will be remaining, and then from here 2 will be remaining, so 252. So see, always don't just leave it like this, okay? You always have to simplify as far as possible, okay? And then when you cannot simplify any further, then you leave it, okay? So let's simplify 252 to taking prime factorization. 2 1 to 2, 2 to the 4, 2 6 are 12, 2 6 are 12, 2 3 are 6. I guess that's it. Can we do more? 2 6 2 3. Yeah, we can do more. 3 3 to the 6, 3 1 to 3, and then 3 7 to 21. Now we can't do anymore. So this can be written as 2 into 2 into 3 into 3 into 7, right? Equal to BC. Huh? As you already know, under the square root, whatever pairs you have will come out of the square root and become single. So these 2 combines becomes 1, these 3 combines becomes 1, and since this 7 has no pair at all, this 7 still remains under the root. So this, therefore BC equal to 2 into 3, 6 root 7. Okay, hence distance of stack from pole equal to 6 root 7 meter. Okay, that's it. So let's do number 11. Number 11 is a little complicated, but it's not that hard also. Okay, so before we do that, let's draw the diagram, okay? An airplane leaves an airport and flies due north. Let's say north is this side, north, right? At a speed of 100 kilometer per 1000 kilometer per hour. So 1000 kilometer per hour. Remember, this is speed, okay? We cannot measure the side of a triangle using speed. We cannot say like what's your weight, and you can't say 20 kilometer, right? Or 50 kilometer. You cannot present weight with kilometer. Just like that, we cannot say the distance between two places, okay, because even if I am drawing a line, this line has a distance from one place to another place. So even in a triangle, even the sides are measurements of distance only, even if it's small, right? So we cannot measure distance by speed. Always remember that. So you need to find the distance first, okay? So we have, let's say this is the original place. From the origin, one plane is going to the north, another plane leaves the same airport, so which means from the same origin, same airport, and flies due west. So let's say this is the west. So another plane is going west at a speed of 1200 kilometer per hour. So this is speed, okay? Don't forget speed. This is also speed, not the distance. So we don't know the distance of the, so they're saying this plane is going this side, this plane is going this side. Let's say after 1.5 hours, this plane is here and this plane is here, okay, after 1.5 hours. So they're asking us find the distance between the two planes. So after 1.5 hours means this thing planes took off at the same time, okay, and then exactly after 1.5 hours they're asking us what is the distance between the two planes, right? So since they took off from the same time, they both took 1.5 hours, 1.5 hours, both, right? So let's start by writing, let's say speed of plane A, plane N, which went to the north, okay, equal to 1000 kilometer per hour, okay. Speed of plane W, which went to the west, is 1200 kilometer per hour. Time taken by both planes, time taken equal to 1.5 hour, or 1.5 hour we can make it into, this is in mixed fraction, we can make it into improper fraction. So 2 plus 1 is 3/2 hours, right? Now we need to find the distance, because we have to apply Pythagoras theorem in order to find the distance between these two. But in order to find the distance between these two, we need the distance between this and this and this and this, right? So to find the distance, we know that, see, speed, this is the speed. Speed, we're writing 100 kilometer per hour, which means speed equal to kilometer dot distance la or hour dot time la. So since we need to find distance, I'm going to leave d here and then set everything that's it. So if t goes this side, it'll become multiplication. So s into t equal to t. That's how I remember this formula, okay, in case you forget in examples. So now distance of plane N equal to, or distance traveled by plane N. I think there will be a better English, but whatever. This is of plane N equal to speed into time. Speed of plane N is 1000. Time is 3/2 hours. So if I cut this, it will be 500. So we're getting 1500 kilometer. That's the distance it traveled. So from here to here, it's 1500. Okay. Now, distance traveled by plane W, the one that went to the west, equals speed into time. Speed in this case is 1200. Time remains the same, 3/2. If I cut this is 600. So 600 into 3 is 1800 kilometers. So this plane traveled 1500. This plane traveled 1800. Okay. Now we know the distance between these two and distance between. Now we have to apply Pythagoras theorem to find Wn. I'll just do it here since this is going to be a little lengthy. So in triangle NWO by Pythagoras theorem, we can say NW square equal to NO square plus WO square. Nah? NW we have to find out, so we don't know, but NO we know that NO is 1500 squared plus this is 1800 squared. So since I don't want to square such a big number and do the prime factorization of such a large number, what I'm gonna do is I'm gonna write this as this, okay. I'm gonna write this as 15 square into 100 square. Can we do that or not? Because 1500 can be written as 1500 square. So I can write 15 into 100 square. 1500 I can write as 15 into 100, because 15 into 100 is 1500 only. But since square is on both, I can share the square and just keep it like this, right? So instead of 1500 square, I can write 15 square into 100 square. Why? Because this is how it came to be. Okay, you have to understand that. So even for 1800 square, you can write 18 square into 100 square, right? Now NW square, since 100 square is here, 100 square is here, and both are multiplication, in the middle there is an addition, we can take 100 square common. So if we take 100 square common, in the middle there will be left 15 square plus 18 square. So now if I send the square this side, I'm doing all of this so that my calculation is short. Okay, you can literally square the whole thing, add the whole thing, and then find the square root of the big number, whatever you get. Okay, you'll get exactly the same answer as me only. So in case you don't understand, you can do that also. So this square root, I send it this side, it will become square root. This will become 100 square. So 15 square is 225, I suppose. 18 square, I have no idea. I have to calculate. Wait. 18 square, 8 is 64, 4, 6, 8, 1 is 8, 14, right? 18. 4, 2, 1, 3. 324. So 18 square is 324. Okay. So NW equal to, see, 100 square, this is into bracket as well. Okay, let's just to make it simple, I'll just do like this. I won't remove the 100 square now. I'll add this and then remove the 100 square. Okay, 2 to 5, 9, 4, 5 into 549. So now 100 square literally means 100 into 100, right? 100 into 100 so 100 tuita, and whenever I say square root under the tuita pair like that, so 100 into 100, 1 will come out, it will become 100, and remaining 549 will remain. So if we do prime factor, I have already told you we have to simplify as far as possible. So if we do prime factorization, we know that 5 plus 4 is 9, 9 plus 9 is 18, which means 3 will be divisible. So 3 ones are 3, 2 in hand, 3, 8 are 24, 3 is 9, 8, 9, 10, 11, 12. So we can still divide by 3, 3, 6, 18, 3 ones are 3. 61 is, I think it's a prime number, so we cannot do anything. So NW equal to 100 root over 3 into 61. This has a pair, so it'll come out of the root and multiply with whatever is outside, and 61 will remain. So NW equal to 300 root 61. So that is our final answer. So therefore, distance between the planes equal to 300 root 61 kilometers. So that is it. So let me just rearrange this. So write it down. So the thing is that maths, it's always good to, whenever there's big numbers, it's always good to take shortcuts and calculate. Okay, so let's do number 12. Last question for this video. Two poles of height 6 meter and 11 meters stand on a plain ground. Okay, so there's a pole here and there's another pole here, because one is taller and one is shorter. Okay, 6 meter and 11 meter. So one is 6 meter, one is 11 meter, and the distance between the feet of the poles, so this pole and this pole, the distance between the feet is 12 meter. Find the distance between the tops. So we need to find the distance between the top. So let's say this A, B, C, D, and let's draw a parallel line to this, to the ground. So this will be, let's say, E. Okay, so since this is also a pole, since this is also a pole, this will be 90, this will be 90, right? So if both are 90 and these two are parallel, the distance between AB and the distance between EC will always be same. Okay, so the distance between these two will also be 6 meter. So from here, okay, from here till here is 6 meter, right? but from here till here is 11 meter. So which means if I want to find the distance between these two, I just have to subtract 11 minus 6, or this will be 5, because 5 plus 6 is 11, right? So we have 11 here, 5, I mean, sorry. This will be 5 from here to here, okay? And since we are talking about two poles, straight poles, the distance between this and this will be 12 only, because on the ground it is 12, so here also it will be 12. So literally we can use Pythagoras theorem on the top. So let's say let AE be a line parallel to BC. Therefore AE equal to BC equal to 12 meter, and then we can say EC equal to AB equal to 6 meter. Therefore DE equal to 11 minus 6 equal to 5 meter. Okay, now in triangle DAE by Pythagoras theorem, we can say AD square equal to DE square plus AE square. AD we don't know, so AD square equal to DC, I mean, sorry, this is DE, okay. DE is 5 square plus AE is 12 square. So I'll just shortcut for you, okay? Send root over this side, 25, 144. AD equal to root over 169, 169 square root to 13. So that is the answer, and that